Hello everyone, welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video I'm going to be walking you through the solutions to the most recently concluded January 2024 Caribbean Examination Council or Caribbean Secondary Education Certificate Examination for Mathematics. Of course, if this is the first time here on the channel, do not forget to hit the subscribe button below, turn on your post notification bell, of course, to be notified on a daily and weekly basis where I post mathematics content to help students to become more proficient at passing their exams on a yearly basis. Of course, if you have any positive questions or comments, leave them down below. And of course, before you leave this video, do not forget to hit the like button. It really does help the channel to grow and to get other students who are in fact preparing for their exams on a yearly basis. Now, of course, as I said before, I'm going to be walking you through the solutions to this particular paper. I am hoping that I can actually do this particular paper here in 3 parts. The first of this video will be the first 5 questions, and then of course I'm gonna be doing the other part of the paper to complete the exam. Of course, let's walk you through the instructions for this particular paper. It says here that this is paper 2. This is the general proficiency exam, and it is in fact 2 hours and 40 minutes long. And some basic instructions that you guys should get accustomed to from now is the fact that this paper consists of 2 sections. That is in fact section 1 and section 2. Section 1 has 7 questions and section 2 has 3 questions. So basically you guys have say here 2 hours and 40 minutes to complete 10 questions. You're required to answer all questions, writing your answer in the spaces provided in this booklet. And it says your numerical answers that are non-exact should be given correct to 3 significant figures or 1 decimal places, and for angles in degrees unless different level of accuracy is specified in this question. Now, do not write in the margins. All working must be shown clearly. Of course, as usual, a list of formulas is provided on page 4 of this booklet. If you need to rewrite any answers, there is not enough space, you can do so on the original page. All right, so it just basically just runs you through the basic rules for an examination. So we're not going to be going through all of that. Of course, you're allowed to use a calculator, and of course you need to have your geometry sets. Now, these are the formulas that CSEC does provide for you here on the exams. And of course, you're given the volume formula, the volume of a cylinder, the volume of a right pyramid, circumference, arc length, area of a circle, area of a sector, area of a trapezium, roots of the quadratic equation, your trig ratios, sine, cosine, and tangent, and the area of triangles given different dimensions. Of course, you have the sine rule and the cosine rule. All right, so those are the basic rules. Now, of course, we start off here. We have 2 hours and 40 minutes. So let's get right into the video. Of course, do not forget to subscribe to the channel as we prepare for our exams in the coming few months. All right, now here we go. It says here that for question 1a, we are to express as a single fraction in its simplest form 1 minus open bracket 1 over 30 plus 4 over 15. All right, and so of course PEMDAS takes precedence here. We are in fact going to be working out what is in the bracket first. All right, so here we go. So we have, say here, we're going to put this 1 over 1, and we're going to minus then, say here, 1 over 30 plus 4 over 15. And so here we're going to be finding the LCM of this section of the problem then. And so the LCM here is in fact 30. Okay, so we have 30 into 30 goes 1 time, that's times the top by 1, and 15 into 30 goes 2 times. Then we end up, say here, with 1 times 1 is 1 plus 4 times 2 is in fact 8. So we end up here with 9 over 30. And so therefore then we can reduce this fraction then by using a factor of 3. So 3 into 9 goes 3 times, and 3 into 30 goes, say here, 10 times. So the answer for what is in the bracket is in fact 1 over 10. Now we can therefore then go ahead and use the 1 over 1, and we're going to minus, say here, 3 over 10. And once again we're going to be finding the LCM, which is in fact 10. So 1 into 10 goes 10 times it by the top, and 10 into 10 goes 1 times it by the top. So 10 times 1 is in fact 10, and 3 times 1 is in fact 3. So we get a final solution here of 7 over 10 as a proper fraction. All right, so pretty easy there. We end up getting 2 marks for that. You could actually go ahead and find the LCM for the whole entire fraction, but since as they place this in a bracket, it does only make sense that we do whatever is in the bracket first. All right, so that is 2 marks. All right, so let's go ahead then and read this question. 2-story car park has a total of 1,020 parking spaces. At 0630 hours one morning, 1/30th of the 120 spaces are filled. During the next hour, no cars left the park, but another 4/15 of the 120 spaces are filled. Determine the number of parking spaces that are not filled at 0730 hours. All right, so this is a very interesting question here that CSEC has sent. So this requires us then to say here that of the 1,020 parking spaces at 6:30 in the morning, then you find here that 1/30th of the spaces are filled. So let's go ahead and find out at this point at 6:30 how many cars were filled. So it's going to be 1 over 30 multiplied by 1,020. And so then we can go ahead then and cancel, say, zeros, or we can just go on our scientific calculator here and say 1,020 divided by 30, and that gives us 34. So that's boom, 13 to itself 1 times, 13 to this goes 34. So at 6:30 in the morning we had 34 spaces that were filled. All right, beautiful. Let's have that written down there. And so from the 34 spaces, then we went on to say here, during the next hour, no cars left the park. However, though, another 4/15 of the 120 spaces are also filled. So it's 4/15 of the 1,020. All right, so that's 4 over 15 multiplied by 1,020. And so again, then we can say 1,020 divided by, say here, 15. That should be 68. It's double the 34. All right. So therefore, then we end up with another 68 car spaces. Pardon me, guys. Spaces were filled. Alright guys, so I did make an error here, as you see me writing here on screen. After dividing the 1,020 by 15, I got 68. I did not multiply the 68 times 4, so I should have gotten 272. What I want you guys to do for me is just continue listening as you watch the video, but make the corrections on your paper using the number 272. That means wherever I have placed 68, you're going to put 272 there, and then do the adjustment in your calculations. I just recognize that I did make an error while editing the video. All right, thank you so much guys for being patient. Let's continue listening in to the remaining solution. 918 car spaces that are currently not filled. All right, so we get a 1 mark for that. All right. And then I guess it's just 1 mark, so we didn't have to do that much work. There might be another way. We could have added the 130 to the 415s and then find it as a fraction of 120. So there's a couple of ways to go around that, but I think CSEC was a little bit stingy on the marks there because I think that required a little bit of thinking. However, let's continue here. Of the 1020 parking spaces, 20% are on the top level. How many parking spaces are on the top level? So it's just going to be 20 over 100 multiplied by, say here, 1020. All right, so we could just use this 0, cancel this 0, and this 0, cancel this 0. So we end up with 2 times 102, and that's going to be 204 cars are on the top level. On 204 cars on the top level. All right, nicely done there. All right, so let's just move on. We're about 11 minutes into the video. Let's just continue down here. Now, some of the spaces are reserved for monthly paying customers. The ratio of the reserved spaces to non-reserved spaces is 5:7. Calculate the number of non-reserved parking spaces. All right, this is pretty simple, guys, because this is a ratio. This is a proportionality here. So what we're looking at then is, firstly, let's just write down the ratio here. It says that it is the ratio of, it says here that the ratio of reserved to non-reserved. So let's just write reserve to non-reserve, and that's going to be 5:7. All right, so the first thing that we do is just write down our ratio, 5:7. So I can therefore then go ahead then and say here then that 5 plus 7 gives me a total proportion of 12. Yes, so that then means then that 12 shares is going to be equal to the 1020 spaces. Yes, and so therefore then 1 share is going to be equal to 1020 divided by 12. So we must add the individual shares in our ratio. So if you go ahead then and we say 1020 divided by 12, we're going to get 85. Yes, so 85 is 1 share. Now the question specifically asked to calculate the number of non-reserve, and non-reserve is 7, so that's going to be then in fact, so here therefore it is 7 multiplied by 85, and so that is equal then 85 multiplied by 7, that gives us 595. All right, remember guys, I'm doing the question live. I actually did not see this paper. I don't particularly focus a lot on past paper questions. Sometimes the papers are released and I really don't see the paper. I'm just now looking at it because I'm, of course, upon making this video, my students were 2 months before the examination, so I thought that this would be a good idea to walk them through this particular paper then. All right, again guys, do not forget to hit the subscribe button below, turn on your post notification bell, leave a like. Of course, I'm going to be posting more videos like this if you guys need these early preparations for exam. All right, let's continue down here then. Part E seems as if it's all connected. The cost for parking at the park is shown in the table below. So if you park under 30 minutes, it is free. More than 30 minutes and up to 2 hours, 2.25, more than 2 hours, up to 4 hours, 5.50, more than 4 hours, up to 8 hours, 9.25, more than 8 hours, up to 24 hours, $15. 1 week ticket is a $40 charge. All right, so it says here that Michaela leaves the car park at 1830 hours, that is 6:30 in the evening, and she pays 9.25. Determine the earliest time she could have arrived at the car park. All right, so here's it. So what we're going to be looking at here is simply fact that we're going to be doing some subtraction of hours. Now, since $9.25 is for more than 4 and up to 8, we are therefore then going to, since we're looking for the earliest time, we are going to presume that she would have parked for a maximum of 8 hours. Could be less, but we're going to say the maximum because we're looking for the earliest time. And if you notice that CSEC here highlights the word earliest, so the earliest means that we must use the maximum of 8 hours. So if it's 6:30 in the evening and we subtract 8 hours from that, then what we're looking at then is approximately 10:30 in the morning. So that would be, say here, let's just use our regular timing. We're going to say 6:30 in the evening at 6:30 p.m. And if we minus, say here, 8 hours from that, then what you're looking at then is, say here, let's go backwards. It's going to be 5:30, that's 1 hour. 4:30, that's 2 hours. 3:30, that's 3 hours. 2:30, that's 4 hours. 1:30, that's 5 hours. 12:30, that's 6 hours. 11:30, that's 7 hours. And 10:30, that's 8 hours. So therefore then the earliest possible time that she could have parked would have been, say here, 10:30 in the morning. So that's 10:30 a.m. So that was a pretty simple question. You can see there's just 1 mark, so nothing much then. All right, and if you guys are aware of how to subtract hours, it's a very fundamental math. On that, I'll pin a link in the description of the video below where you can find a link to learn how to subtract time. All right, let's move on then, say here to this part. Dan Raj bought a weekly parking ticket for $40. That week he visited the car park for 5 different times. The length of time he parked his car on each occasion is given below: 25 minutes, 7.5 hours, 11 hours, 8.75 hours, and 8 hours. So these are the individual times that he parked for. Show that Dan Raj saved $8.50 by buying a weekly ticket. All right, so we know that a weekly ticket is, say here, $40. So $40 is equivalent to a weekly ticket. And so let's check the individual calculations for each time he parks. So here, based on the table, then, if the first park that Dan Raj parked was for 25 minutes, and basically then he has parked under 30 minutes, so he got that particular time free. So there's no charge here. The charge here is going to be, say, $0 on that day. All right, and then so we're gonna add that then to he parked for 7.5 hours. That's going to obviously about $9.25, because 7.5 is between 4 hours and 8 hours. So that's 7.5, so that's 9.25. All right, let's just write that. Good. Okay. All right, so that's $9.25, and then we're gonna add then again the third time that he has parked is 11 hours. So if you park for 11 hours, it says here more than 8 hours but up to 24, this is what he would have paid. So he paid $15 that day. All right, so $15 that day. And then now what we're looking at then is he parked for another 8.75 hours. So 8.75 is a little less. So 8.75 hours, that again would be $15, because 8.75, 3/4 more than 8 hours. So he has to pay another $15 again. All right, so that's $15 again. and then for the last time that he parked for 8 hours, so he can actually pay, say here, up to 8 hours. That's another $9.25. So that's another $9.25. All right, so if you go ahead then calculators, then you're going to find here that this is going to be $15 plus $15 plus 9.25 plus 9.25, and that's going to be, say here, a total of $48. Well, $48.50. Now what you're saying here is that we should show that he saves $8.50 by buying a weekly ticket. So since the weekly ticket would have cost $40, all we're going to do here is just subtract what he actually paid for paying the tickets daily minus what he would have paid had he just bought the ticket. And so clearly then you can see that 48.50 minus 40 is in fact $8.50. Alright, so CSEC really came with the goods here. This question is a really nice analytical question. A question then that requires you definitely to read carefully and think. Alright, so even though the math is very simple, you had to really think that one through. Alright, so that's it basically then. Let's move on then to question 2 then. And this is where we meet the algebra section of the paper. So here now we say simplify, say here, x squared plus 7x all divided by x squared minus 49. So we have to simplify this. Now it looks like we may have to do some factorization here, because of course if you look carefully at this question here at the top, then we see that there's a common factor here of x, and so x divides into x squared goes x times, and x divides into 7 goes 7 times, and that's all going to be divided then by x squared minus 49. This apparently is a difference of 2 squares, so that's difference of 2 squares, and we can recognize this type of expression because of course the first term is raised to a power of 2 and the second number here can be expressed to a power of 2. So x squared is already, say here, then, all right, and then what we're looking at is in fact 7 squared. Now once we're successful in doing that, we know that this is going to be x, open bracket, x plus 7 all divided by, the rule is we're going to open 2 separate brackets and we're going to insert a plus in one of the brackets and a minus in the other bracket, and then we're going to have an x here and a 7 here and a x here and a 7 here. That's the shortcut to writing down a difference of 2 squares. So if you look carefully, then that, say here, this x plus 7 here cancels this x plus 7 here, then our final result then works out nicely then to be x divided by x minus 7. All right, and that is pretty much it then. That's how you would factorize that expression, or that's how you'd simplify that expression. All right, now let's move on then to this part here where it says find the value of r when x squared times x to the 6 equals x to the r. So what we have here is a exponential equation, or we're showing that the left side of the equation is equal to the right side. All right, so this brings to mind then that if you're multiplying then 2 quantities with the same base, then the rule is that we are going to add the powers. We're going to rewrite one of the base and we're going to add the powers. So then what we're looking at then is in fact, say here, x rewrite, and then we're going to add 2 plus 6, and then we're going to equate that to x to the power of r. So then that's x to the 8, and that's going to be equal to x to the r, pardon me, here. Okay, good. So now we have x to the r, and according to the laws of indices, that if the bases are in fact the same and one term is equal to the other, then we simply just drop the power. So 8 is equal to, say here, r. Have not seen a question like this on CSEC paper in a couple of years. As I said, guys, I do not really pay much attention to past paper questions, but I have not seen this type of question. Very simple, but if a student doesn't have the prerequisite skills, this might in fact cause a problem. So hopefully you guys got a hang of that. Hopefully if another one like that comes, that is how you handle the situation. All right, now it says here that we should also go ahead and find the value then of s. S to the power of 3 is equal to 8. So that's s to the power of 3 is equal to 8, and we have to find s. In other words, we need to isolate s. Now, what I'm concerned about, upon reviewing the paper prior to making this video, is that I find that this particular question, they're coming across pretty simple. And most students are sometimes over prepared for an exam, that they're expecting something challenging, when in fact the question can be as simple as cube rooting the left side of this equation and cube rooting the right side of the equation. And so here cube root cancels the cube, so s is equal to the cube root of 8. Now if you know, you know, but if you don't know, what you can do here is that you can write down 8 and choose the lowest prime number that can divide 8, and if you end up with the prime numbers 3 times here, then that's the result. So if you say 2 into 8, that goes 4 times, 2 into 4 goes 2 times, 2 into 2 goes 1, so this is 2 to the power of 3. So therefore 2 cubes equal 8. But again, if you know, you know the cube root of 8 is in fact 2. It's a very simple question then, but sometimes can spook students. So I want you guys that are watching this particular review of this paper, that you've got to be not too over prepared for the exam, because sometimes you can expect a very challenging question and something as simple as this comes on the exam. So you got to watch out for that, guys. Do not overthink the paper. All right, let's scroll on down here to this particular question. Then the diagrams below show a triangle and a quadrilateral. All angles are in degrees and are written in terms of A and B. So we have this triangle over here where one of its angle is in fact written as an algebraic expression. So it is 3b degrees, and then this is A plus 2b degrees, and this is A plus 9 degrees. This quadrilateral here, not anything specific here, has this angle 6a degrees. This is 3a plus 2b degrees. This is 18 plus 3b degrees, and this is 3b minus 2a degrees. Now for the triangle, show that 2a plus 5b equals 171. So this is one of those type of questions where, as opposed to giving you the actual degree and asking you to find it, they're then giving you the algebraic expression and asking you to use the geometric theorem for a triangle to prove a particular equation that we have here. Now what we do know though, what we certainly know about this particular diagram is the fact that all 3 angles in a triangle will sum to 180 degrees. So therefore then what we're sure about here is that if I take A plus 2b here, and I therefore add it to, say here, 3b degrees, and I then therefore go ahead and add that to A plus 9 degrees, what I'm sure about is that the sum should equate to 180 degrees, and that is in fact the internal angle theorem for a triangle in geometry. So now if we can group like terms, then you're going to find then that we have A here, and then we're going to add that then to A over here, that is the A plus 9. All right, and then we're going to group, say here, the B's, so that's going to be 2b plus 3b, and then of course that's going to be plus 9, and we're going to then equate that to 180 degrees. All right, now if we go ahead then and we add A plus A, you'll realize here that we end up with 2A, and if you add, say here, 2B and 3B, you're going to end up with, say here, 5B, and then of course because we're trying to create the equation that we're supposed to prove, we know that we're going to be subtracting 9 from both sides. So if I subtract 9 from the left side of the equation here, the 9s are going to go, or as I would always say in my videos, carry the 9 across here. So we end up with 180 minus 9. And so guess what, students? We have proven what they've asked. 2a plus 5b is equal to 180 minus 9, 171. And we just write here, shown. All right, beautiful. All right, that is how you'd evaluate a question. Let's move on then to for the quadrilateral then. We are to show that 7a plus 8b equals 342. So it's very similar calculation, except that in a quadrilateral, when you sum all the angles, as opposed to being equated to 180, it will be equated to 360 degrees. So we know that one of the angles on the quadrilateral is 6a. So we know that that's going to be, say here, 6a degrees. I'm going to add that to, say here, let's scroll up. That's 3a plus 2b degrees. So that's 3a plus 2b degrees. And again, we're going to add, say here, 18 plus 3b degrees. So that's going to be plus 18 plus 3b degrees. And then, of course, we're going to add this final angle here, 3b minus 2a degrees. So that's going to be plus 3b minus 2a degrees. And that's going to be equal to 360 degrees. All right, let's go ahead then and group like terms. So we have this 6a here, and we have, say here, this 3a here. All right, again guys, if you're advanced enough, you don't have to do all this writing. You can just go right ahead then and just add it mentally. So that's 6a here, that's going to be plus 3a here. Let's scroll along here. We have another 2a out here, so that's minus 2a. Then we have this plus 2b here, and again we have this plus 3b here. All right, and then we have another 3b here. Right, and then that seems to be plus, say here, is that 18? I think, yes, it is in fact 18. So that's plus 18 equals 360 degrees. All right, so 6a plus 3a, that is 9a. 9a minus 2a is in fact 7a. And so 2b plus 3b is in fact 5b. 5b plus 3b is in fact equal to 8b. So already we can see part of what we want, and then of course easily then we're going to have to subtract the 18 from both sides. So that's going to be 360 minus 18, and we can almost bet that, say here, the answer is 7a plus 8b, and that's equal to, if you subtract 18 from 360, you're going to end up with 342, and we have shown the answer. Again, CSEC is a bit stingy with the marks. Not sure why. This works a lot more than 1 mark. Maybe it's a case where you don't have to work this all out like that, but I'm particularly helping a lot of the students who are a bit slower in terms of understanding how to approach the paper. For me, it is more than just about giving you the answer. It is a process. As you're studying past papers, guys, you want to ensure that you indulge in the process of the paper, right? That's how you're going to build up your speed in completing the exam. So we're not even concerned about how many questions we're going to be doing within the hour. If I'm going to be doing this, I'll perhaps do this in 5 parts. So we'll do the first 2 questions, the last 2, then the last 2. So that's how we're going to have to do it, guys. All right, so let's get right into it. Now, next here that we're going to be solving, we're required here to solve the pair of simultaneous equation in part 1 and 2 to find the values of A and B, showing all working. All right, so this is how many marks? 3. CSEC definitely wants us to work here. So the equation that we got in part 1 was 2a plus 5b equal 171. So 2a, pardon me here, guys. So that's 2a. Whoops, let's just write it a bit better. So we end up here with 2a plus 5b equal 171. And and that's going to be equation 1. And it says the equation that we got in part 2 here was 7a plus 8b equal 342. So that's 7a plus 8b equal 342, and that becomes equation 2. All right, beautiful. So I just recently uploaded a video, a thorough review video on simultaneous equation. I will pin yet again a link to that video in the comments or in the description of this video. So if you're a little bit unsure about how to approach simultaneous equation, do check that video out. It will in fact do you some justice then. So of course, say here equation 1 and equation 2, my objective here is to eliminate one of the variable. In fact, here I'm going to be eliminating the middle variable here. So what I'm going to do here is that I'm going to be just multiplying this equation here by 8, and I'm going to then multiply this equation here down here by 5. And how did I get these numbers? I used the coefficient of the bottom equation to multiply the top, and the coefficient of the top equation to multiply the bottom. So then of course 8 multiplied by 2a, that is going to be 16a, plus say here 8 multiplied by 5b, that is 40b, and that's equal to 8 multiplied by 171, and that gives us 1368, and that then becomes equation 3. So then 5 multiplied by 7a is 35a, plus 5 multiplied by 8, 5 eighths is 40, so that's 40b, and that's equal to 5 multiplied by 342, that gives us 1710. So that's 1710, and that becomes equation, say here, 4. All right, and so we know the rule that if the signs are in fact the same, we're going to therefore go ahead and subtract equation 2 from equation 1. So if we do then that, what we're going to find then is 16a minus 35a gives us negative 19a, and of course 40b minus 40b is 0, and so of course 1368 minus say here 1710, that's going to give us negative 342. So that's negative 342. All right, and so of course negative 342 will divide by negative 19, and you find that a here is equal to 18. All right, and now that we've gotten the value of a, we're then going to go ahead then and we're going to write a statement here. We're going to sub say here 18 for a in, we can choose here either equation 1 or 2. I prefer using equation 1 because of the smaller numbers. So wherever I see an a, I'm going to therefore go ahead and put 18 then. So that's going to be 2 multiplied by 18 plus 5b, that's equal to 171. So 2 multiplied by 18, that's going to be 36 plus 5b equals 171. And so if we subtract 36 from both sides, you find that 171 take away 36, that's going to give us, say here, 5b is equal to 171 minus 36. 5b is equal to 135. So therefore then if we split the product, then b is equal to 135 divided by 5, and so that will be equated to say here 27. So b is in fact 27. All right, and they did say that we should show all working. So that's it. That's how you attain those 3 marks, guys, for that simultaneous equation. So nothing too unfamiliar, just a bit bigger numbers than we're accustomed to working in class, but of course it is more or less the same. All right, of course, guys, if you are in fact enjoying the channel, you're enjoying the video, you're enjoying the tutorial, and you're feeling a bit more confident, do not forget to hit the like button before exiting this video, and leave your thoughts and your suggestions down in the comment section below. All right, now let us see if we can wrap up, say here, in the next 20 minutes. let's see if we can wrap up question 3 and 4, give or take. We will just therefore go ahead and just do question 3. So here in triangle ABC, AC is equal to 8 and BC is equal to, say here, 5 centimeter. Use a ruler and a compass only to construct triangle ABC. The line AB has been drawn for you. So let's see here, that's the line AB. Now, unfortunately, guys, I do not have the digital tool to show you the whole compass and how to scribe the arcs, but I'm going to demonstrate verbally as best as I can. So what I want you guys to do is to take out your geometry sets for me now and just follow my exact instructions. You should be okay. All right. So what you're going to be doing here, guys, is that you're going to be taking out the instrument, the compass. That is in fact the one where you insert the pencil in and it has one needle. And I also want you to take out your protractor. Now what I want you to do is that I want you to make the pencil, after putting the pencil in the compass, ensure that the pencil and the needle are on the same, let the pencil be a little bit shorter, just a little bit shorter than the length of the needle. All right, so the pencil should be a bit shorter then. All right, now what I want you to do for me here, guys, is let's go back here. It says that triangle AB is 8 and BC is 5. So we have AB, so AC is 8, so we have AC here. So we're looking for C, that's what we're looking for. And so what we do know is that, say here, if BC is 5, we can basically open the compass to 5 centimeters. So place your ruler on the table or on a hard surface, hold it with your 2 fingers, stick the needle at 0 and open up the pencil up to 5. Now you're going to place the needle here at B, and with that radius of that compass you're going to scribe an arc like that. All right, and so that's from B to C. All right, and then what you're going to be doing now, it says that from A to C then is 8. So from A to C then is 8. You're going to place the ruler again on the table, you're going to place the needle at 0 and then open the compass to 8 centimeter. Then you're going to place the needle here at A with that radius, and then you're going to basically scribe an arc. All right, and so by scribing an arc you should have something looking like this as you see here on screen. Then you're going to then take your ruler then and draw a line, say here from A all the way to the point of intersection here, and then from B connect your ruler from here to here. Of course your diagram may not look like this because of course I did not use any digital tool, I just make an estimation. So let me know in the comments if you end up with a triangle looking exactly like mine. This would be really good for me because I literally did not use a compass or anything here. All right, and that would be your triangle ABC. So the point of intersection here is in fact C. All right, so let me know in the comments, guys. I would love to know if you got it right then. All right, now you are to measure and state the value of the angle BAC. So BAC, we're looking for this angle here. Again, guys, unfortunately, I would not be able to measure this for you. So I would have to physically do this here. I did not do the paper. This is actually the first time I'm seeing the paper. So unfortunately, I would be able to provide you with the answer for that. But let me know in the comments what you guys get and let us engage. Let me know what this angle is. All right. All right. So hope. All right, good. So I don't need that information to carry on to the next question. All right, so here we go then, guys. The diagram below shows an equilateral triangle FGH whose base is 13 and its height is h. So isosceles triangle, we know that for an isosceles triangle the two sides are equal, and so right away then we can safely say that the base angles as well are equal because the equal angles are opposite to the equal side. All right, and then we know that we have a height here that is drawn perpendicular, so this is a 90-degree angle here. So already I know if it's an isosceles triangle and I have a perpendicular, then it also then literally means that this side here is equal to this side here. So I know that the 13 here has been split into 6.5 and of course 6.5. The only time you can say this, guys, that the base has been split into a half is if it's an isosceles triangle. If it's just a scaling triangle, it doesn't necessarily mean that the base has been chopped in a half. This can only be applied if it's an isosceles triangle. All right, so valuable information there. Let's go on then to see what they have said here. Calculate the value of h. All right, so do we have any information here? We know that this is 90. All right, and let's see here. All right, guys, so I think I may have misread the question. It did not say an isosceles triangle. It in fact said an equilateral triangle. I completely missed this here. All right, but we're still good on the 6.5 and the 6.5, but I know that if it's an isosceles triangle, then this angle here is in fact going to be, say here, 60 degrees, and this angle up here is 60 degrees, and this angle here is also 60 degrees. So my apologies, guys. I was assuming that, I'm not sure what I read. I could have sworn I saw isosceles, but it is in fact equilateral. So this is even better. So all the angles are 60. So to find h then, since h is a side on the right angle triangle, we may have to use a trig ratio. So based on the rules that I've given a lot of my students here, and I will pin a link to my sine, cosine, and tangent practice paper video, you can check that out, how to use the sine, cosine. But what we do here is that we go ahead then and we name our sides. So since given to us here is the 60 degree, then h becomes our opposite side. Of course, we know that the 90 degree faces the hypotenuse, and of course this 6.5 down here is now our adjacent. So given the adjacent here 6.5 and we're asked to find the opposite, then it looks like we're going to be using the tan ratio. So tan theta is equal to opposite over adjacent. Therefore tan of 60 degrees is equal to the opposite side, which is h, over the adjacent side, which we have split the 13 into 2 halves, that is 6.5. All right, so if you go on our calculator then and we find, say here, tan 60, we'll find that tan 60 is 1.732, and therefore then that's going to be equal to h over 6.5. And of course the rule is that once your unknown is at the top of the equation, then we're going to cross multiply. So h then is equal to 1.732 0.050808 times that now by 6.5. We end up that h is equal to 11.25. It says, did it specify to one decimal place? No, it didn't. So I'm just going to round this out to the nearest one decimal place. So that's 11.3 centimeter. All right, so that would be the length of h here in the middle. So let's just make a mark on that. Ensure that this information probably is going to be valuable later. Let's see. All right, moving on then down to, say here, the part C. So okay, so it's definitely not connected to this, and that was it. That was really it. That's all that we got for trig. All right, so a little bit over expected. A lot of students may have not expected that the exam was going to come this simple. The questions are in fact way simpler than a lot of the things that I taught my students in my class currently. So I hope you guys are in fact watching and recognizing here that this particular paper is simpler than you think the exam is. You can see that there's not a lot of work in our. The diagram below shows 3 triangles P, Q, and R. Triangles Q and R are images of triangle P after it undergoes a double transformation. So we know right away that triangle P is going to be, say here, my object, and these two are in fact separate images of triangle P. All right, so let's call that I and I. So they're separate transformations. All right, so here it says that we should describe fully the single transformation that maps triangle P. So we want to know, how did this triangle here end up being this one here? And my students and I have talked a lot about this. I recognized, even though I have not been paying much attention to the past papers over the past recent years, what I see is that CSEC tends to ask this description of the transformation a lot. So a couple of questions. So students get used to identifying the properties of a transformation. And so when we look at triangle P compared to triangle R, you recognize that they are in fact similar and they are in fact congruent. All right, the orientation apparently has not changed. There's no flip, there is no turning effect, there's no reduction or enlargement, magnification. So by process of elimination, then it only makes sense that P mapping onto R is in fact a translation, because translation is the only transformation where the object and the image orientation remains the same. So that's the only one. If it's a reflection, it tends to turn backwards and the points do some flip and change in signs. If it's a rotation, that also undergoes some flipping the coordinates and changing signs. And if it's an enlargement, then the coordinates tends to double or cut in a half or triple or cut in a third. So right here then, just by process of elimination, it's a translation that maps P onto R. But they did say describe fully. That's what they said. They said describe fully. So when you're describing a translation, guys, remember to write not only that it's a translation, but you must state the vector that translated it. So we simply write then that P maps onto R describes, all right, ensure that you guys write it like this, describes a translation by the vector, and the translation vector, or what we call the displacement vector, is in fact a 2 by 1 metric. So basically then we need to find out pretty much how did we get from here to here, and of course how we get from here to here, from here to here, and also it's going to be the same as how we got from here to here. So all we need to do is just to check 1. So right away I know that from this position right here I had to take 2 steps to my right, and then if you recognize then that after taking 2 steps to my right, that's 1, 2, we had to take 1, 2, 3, 4 steps up. So the displacement vector then is going to be, say here, 2, 4 written in a column form, 2 by 1 matrix. All right, so P maps onto R describes a translation by the vector 2, 4. All right, we could actually use the formula O plus T equal I, and then we could do some matrices subtraction, but I mean this is a short way, it's just 2 marks and it requires just a description. Now how did R map it? So how did R, this one up here, let's erase all of this here, it's a little bit confusing for the next question. So what we're looking at then is in fact how did R land onto Q. So you can see that it's a reflection, because obviously you can see that the image Q is a complete mirror of the object. In this case here, the object now is R. Q is the image of R. All right, both Q and R are images of P, but of course say here Q is the image of R. Now When we talk about reflection, there are 4 standard reflection that you must remember. That is a reflection in the x-axis, a reflection in the y-axis, a reflection in the line y equal x, and a reflection in the line y equal negative x. But there are in fact what I would refer to as some non-standard reflection. They are reflecting in what is known as parallel lines. So you have a reflection in parallel to the y-axis, and you have also a reflection in the line parallel to the x-axis. Now, in order for us to find the parallel line, to find the mirror line, we must then calculate the distance, the unit distance between the corresponding vertices. So here, if we say here, circle this one here, so if we circle this vertices here and this vertex here, pardon me, we'll see that the distance between this is 1, 2, 3, 4. You'll also recognize that the distance between these two corresponding vertex is 1, 2, 3, 4. And you'll also notice it's the same thing here, that is 1, say here, 2, 3, 4, 5. Okay, so that's 1, 2, 3, 4, 5, 6. So the distance between the two bases here is 6. The distance here is 2. The distance here is 2. So if we chop this distance, say here in a half, so 4 divided by 2, we land right here. Again, if we say 4 divided by 2, we also land right here. And if we say 6 divided by 2, you find out that this is 1, 2, 3 right here. So you recognize that these 3 points basically align themselves in a straight line. So this basically then becomes our mirror line. All right, this becomes our mirror line. And if you notice, it's actually passing through 1 on the x-axis. So R maps itself onto Q is a reflection in the parallel line to the y-axis that is in fact x equal 1. All right, so let's just write that in description so you see how much thinking we had to do to get to that answer. That's the analytical skills that I want you guys to develop. So here we see R is mapped onto Q, describes a reflection in the line x equal 1. All right, and the line x equal 1 is in fact parallel to the y axis. All right, so there you have it, guys. We've done the first 3 questions in under an hour. Remember that the purpose of this video is not to go through the paper under 240 minutes, 2 hours and 40 minutes, but is to help you guys to develop the analytical skills that you need to, in fact, say here, approach the paper. You must have an understanding of what is it that you guys are in fact doing when it comes to, say here, approaching the questions. You must be able to think your way through. All right, let me know in the comment section, do you think that these first 3 questions were difficult, were they challenging? What are your thoughts? Leave it down in the comment section below. Let me know if you think that maybe this is an exam that you might have overthink, or just let me know, guys. All right, so I do really appreciate you guys that have watched this tutorial video here. Please look out for question 4, question 5 and 6 again in another very detailed and elaborate video. All right, so again, before you go, do not forget to hit the like button, do not forget to subscribe to the channel, and do not forget to turn on your post notification bell when I post my next couple of tutorial lessons. So until then, take care, bye bye.